Hello everyone, this is Carlo G. Valdez from BSN Mathematics 2E. So in this video, I will teach you how to find derivatives of an expression using different rules. The constant rule, power rule, the product rule, quotient rule, and the chain rule. So let's get started. Derivation using different rules. Calculus 1. So what is derivatives? Derivatives are the result of performing a differentiation process upon a function or an expression. There are three notations that we can use to express derivatives mathematically. The Lagrange's notation, f quit, pronounced as f prime. Leibniz's notation, dy over dx and d over d of x. And Newton's notation, f point and y point. Different rules and derivation. There are 5 different rules that we will use in this video. Constant rule, power rule, product rule, quotient rule, and chain rule. Constant rule. Constant rule tells that the derivative of k is equal to 0, where k is constant. We can use this rule if the given is constant, just like the example on the right side. 1 e pi 1/2 pi r over 4. And also we have the constant multiple rule. It tells that the derivative of k times f of x is equal to k times the derivative of f of x. We can use this rule if the given expression is constant times a function, just like the example on the right side. 2x squared, 4x, negative 6x to the power of 2, and x over 2. X over 2, we can rewrite this as 1/2 times x, where 1/2 is constant and x is our f of x. And then now let's talk about the power rule. So this is the formula of power rule. Power rule says that the derivative of x to the power of n is equal to n times x to the power of n minus 1. We can use this rule if the given function is in the form of x to the power of n. Like the example on the right side, x to the power of negative 1/2, where negative 1/2 is our n, x to the power of negative 3, where negative 3 is our n, x to the power of 4. And also, we can use the power rule to find derivatives of functions like 1 over x, cube root of x, cube root of x squared. To do that, we first need to rewrite those functions as x to the power of n, like the 1 over x. We can write this as x to the power of negative 1. Cube root of x, we can write this as x to the power of 1 over 3. And x and cube root of x squared, we can write this as x to the power of 2 over 3. Then now, product rule. The product rule says that the derivative of f of x times g of x is equal to the derivative of f of x times g of x plus f of x times the derivative of g of x. We can use this rule if the given function is in the form of multiplication, like this, f of x times g of x. We can use this rule in some expressions like in the example at the right side. X squared times e squared, sine of x times x squared, 1 over x cos of x, e to the power of x times cos of x, square root of x times sine of x, square root of x times cos of x. Then, the quotient rule. The quotient rule says that the derivative of f of x over g of x is equal to the derivative of the numerator f of x times the denominator g of x minus the numerator f of x times the derivative of denominator g of x divided by the denominator square. We can use this rule if the given function is in the form of fraction, like this, f of x over g of x. Here are the examples of expressions that we can use quotient rule in finding the derivatives. Cos of x over x, square root of x over sine of x, 2x plus 4 over x plus 1, square root of x over cos of x, sine of x over x squared, 5 minus 3x over x squared plus 3x. Then now, chain rule. The chain rule says that the derivative of f of g of x is equal to the derivative of f of g of x times the derivative of g of x. We can use this formula if the function is composite function. So what is composite function? A function is composite if you can rewrite the function into the form of g of x. In the other words, it is a function within a function or a function of a function. In chain rule, the composite function consists of inner and outer. So in f of g of x is our inner and the f of x is our outer. For example, cos of x squared is composite. Why? Because if we let f of x is equal to cos of x and g of x is equal to x squared, then cos of x squared is equal to f of g of x. Therefore, chain rule can be used in this example. So other examples of expression that chain rule is applicable. Cos of 2x squared. 2x squared is our inner and cos of x is the outer. Square root of 3 plus 2x squared, where 3 plus 2x squared is our inner and the square root of x is our outer. Then e to the power of 2x plus 4, where 2x plus 4 is our inner and e to the power of x is outer. Then 2x squared minus 4 to the power of 3. So in this function, 2x squared minus 4 is our inner function and the x to the power of 3 is our outer. So cos of squared of x can be written as cos of x to the power of 2, where cos of x is our inner and the x to the power of 2 is our outer. But before we go to the application of the different rule, we must know first the derivative of some function that is very useful in finding derivatives of other functions. So the derivative of e to the power of x is equal to e to the power of x. The derivative of natural logarithm of x is equal to 1 over x. The derivative of sine of x is equal to cos of x. The derivative of cos of x is equal to the negative sine of x. The derivative of tangent of x is equal to 1 over cos of x squared, or secant x squared. The derivative of cotangent of x is equal to negative 1 over sine of x squared, or cosecant x squared. The derivative of secant of x is equal to sine of x over cos of x squared, or tangent times secant of x. The derivative of cosecant of x is equal to negative cos of x over sine of x squared, or negative cotangent of x times cosecant of x. So it is important to memorize or to familiarize this for us to easily find the derivatives of other functions. Application of rules in the given function. Constant rule. So find the derivative of 3. Our given is 3, which is constant. So let's apply the constant rule. So the derivative of 3 is equal to 0. So the answer in our problem is 0. The second problem, find the derivative of the function 1/2 times x squared. The given expression is 1/2 x squared. This expression is in the form of k times f of x, where k is equal to 1/2 and f of x is equal to x to the power of 2. So let's apply the constant multiple rule. So the derivative of 1/2 x squared is equal to k times f prime of x. So k is 1/2 and the f prime of x is derivative of x squared. So the derivative of x squared is 2 times x to the power of 2 minus 1. Then, so 2 minus 1 is 1. So x to the power of 1. So let 1/2 times 2x is equal to 2x over 2. So 2x over 2 is equal to x. So the answer in our second problem is x. Now let's do the power rule. Find the derivative of the function square root of x. The given expression is square root of x. Since we cannot apply directly the rule, since it is in radical form, we must rewrite into the form of x to the power of n. So the square root of x can be written as x to the power of 1/2. So from radical square root of x, we have x to the power of 1/2, or n is equal to 1/2. So now let's apply the power rule to find the derivative of the square root of x. So our n, so substitute, so n is equal to 1/2 times x to the power of 1/2 minus x. So let's simplify. So 1 over 2 times x to the power of 1/2 minus 2 over 2 is equal to 1/2 x to the power of negative 1. We can rewrite this into this form. So 1 over 2x to the power of 1/2, or 1 over 2 square root of x. So the derivative of the function square root of x is 1 over 2x to the power of 1/2, or 1 over 2 square root of x. Now let's proceed to product rule. Find the derivative of the function 1 over x times cos of x. The given expression is 1 over x cos of x. Our function is in the form of f of x times g of x, where f of x is 1 over x, or it can be written as x to the power of negative 1. Our g of x is equal to cos of x. So let's find the derivative of the given function using the formula of the product rule. So the derivative of 1 over x times cos of x is equal to f prime of x times g of x plus f of x times g prime of x. So let's substitute. So our f prime of x is the derivative of x to the power of negative 1, and our g of x is cos of x, plus our f of x is 1 over x. So times the derivative, the g prime of x is the derivative of cos of x. So let's find the derivative. So the derivative of x to the power of negative 1 is negative 1 times x to the power of negative 1 minus 1. then cos of x plus 1 over x times the derivative of cos of x is negative sine of x. Let's simplify. So negative 1 times x to the power of negative 1 minus 1 is negative x to the power of negative 2. Then cos of x, then 1 over x times negative sine of x is equal to negative sine of x over x. So let's rewrite the negative x to the power of negative 2 to eliminate the negative exponent. So negative 1, we have negative 1 over x squared times cos of x minus sine of x over x. Then let's multiply negative 1 over x squared times cos of x, and we have negative cos of x over x squared minus sine of x and x. So then let's simplify. Since the denominator of these two expression is not the same, so let's multiply sine of x by x and x times x to make their denominator the same. So we have the same denominator, so let's differentiate this, and we have negative cos of x minus x sine of x over x to the power of 2. So the derivative of the function 1 over x cos of x is negative cos of x minus negative x sine of x over x squared. And now let's use the quotient rule. Find the derivative of the function x squared plus 2x over 4 minus 5x. The given function is in the form of fraction. In the form of fraction where f of x over g of x. F of x is x squared plus 2x, and our g of x is equal to 4 minus 5 of x. Then let's solve using the quotient rule formula. So the derivative of x squared plus 2x over 4 minus 5x is equal to f prime of x times g of x minus f of x times g prime of x over g of x squared. Then let's substitute. So our f of prime is the derivative of x squared plus 2 of x. Then our g of x is 4 minus 5x, and our f of x is x squared plus 2x, and our g prime of x is derivative of 4 minus 5x. And our squared of x squared, the g of x squared is 4 minus 5x quantity squared. Then let's find the derivative. So the derivative of x squared, x to the power of 2 is 2x, and the derivative of 2x is 2. Then copy 4 minus 5x minus x squared plus 2x. Then the derivative of 4 is 0. Then the derivative of negative 5x is negative 5. So 0 minus negative 5 is negative 5. Then copy the denominator. So let's simplify. Let's perform the FOIL method. The 2x plus 2 times 4 minus 5x. So 2x times 4 is 8x. 2x times negative 5x is negative 10x squared. 2 times 4 is 8. Then 2 times negative 5x is equal to 10x. Then let's perform the distributive property. So x squared times negative 5 is negative 5x squared. Then 2x times negative 5 is negative 10x squared. Then copy the denominator. Then let's simplify. So 8x minus 10x squared plus 8x minus 10x squared. So negative times negative 5x squared is equal to 5x squared. Is negative times negative 10x is equal to positive 10. Then copy the denominator. Then let's combine like terms. So negative 10x squared plus 5x squared is equal to negative 5x squared. Then 8x minus 10x plus 10x is equal to 8x. Then 8. Then copy the denominator. So the answer in our problem, find the derivative of the function x squared plus 2x over 4 minus 5x is negative 5x squared plus 8x plus 8 over quantity 4 minus 5x to the power of 2. And now we have at the last rules, the chain rule, which is my favorite rule in derivation. So find the derivative of the function square root of 4x plus 1. So the given function is in the form of composite function. Why? Because it can be written as f of g of x, where our outer is the f of x, which is square root of x, then our inner, which is g of x, is equal to 4x plus 1. So what the f prime of x is equal to the derivative of square root of x, which is can be written as x to the power of 1 over 2, and the derivative of x to the power of 1 over 2 is 1/2 times x to the power of negative 1/2. So the g prime of x is equal to the derivative of our g of x, which is 4x plus 1. So the derivative of 4x is 4, and the derivative of 0 is, which is constant, so 0. So 4 plus 0 is 4. Then let's apply the formula of the chain rule. So the derivative of square root of 4x plus 1 is equal to f prime of g of x times the g prime of x. Then let's substitute. So our f prime of x is 1/2 times x to the power of negative 1/2, where our x is the g of x, times the g prime of x is equal to 4. Then let's substitute the 1 over 2. Then our g of x is 4x plus 1 to the power of negative 1/2 times 4. Then let's rewrite to eliminate the negative exponent. So from 1/2 times 4x plus 1 to the power of negative 1, we have 1 over 2 to quantity 4x plus 1 to the power of 1/2 times 4. Or we can simplify this. We can rewrite the 4x plus 1 to the power of 1/2 into radical form. 1 over 2 to the square root of 4x plus 1 times 4. Then let's simplify. Let's multiply. 1 times 4 is 4. So we have now the 4 over 2 square root of 4x plus 1. So 4 divided by 2 is 2. So 2 over 4x plus 1 quantity 1/2, or we can written as 2 over square root of 4x plus 1. So that is the answer in our last problem. Find the derivative of the function square root of 4x plus 1. So thank you for listening, and I hope that you learned a lot from this video. Thank you and mabuhay!